I will get your end of topic tests back to you as soon as possible, but your marks will probably either go in over half term or after half term, so watch out for those being returned to you. There are still some of you who have not done that previous topic, the previous topic test. Can you please do that as soon as possible? There are also far too many of you who are not responding to feedback that is given on your work. For example, there are still probably about a dozen of you, maybe slightly fewer, who have not yet completed the work on feedback for formula of ionic compounds. That work was set absolutely ages ago. Some of you have been excellent, you've responded to everything, but others really poor. It doesn't take long to do, but please do it. It makes sure I know that you've done your learning properly. Right, new topic. This is the last topic of this academic year, and it's called quantitative chemistry. It's all about maths, I'm afraid, and the basic skills you need though are only adding and multiplying and dividing, nothing harder than that. So let's make a start. There's one key skill I want you to get sorted before half term, and we're going to concentrate on that in this lesson and the next lesson. Now, weighing atoms. Well, obviously atoms are very small, and they are actually impossible to weigh because, for instance, a single hydrogen atom has a mass of 1.67 times 10 to the minus 24 grams. Okay, obviously that's a really small number. Single carbon atom about 12 times bigger, 1.994 times 10 to the minus 23. I'll let you think why the mass of a single carbon atom might be 12 times heavier than a hydrogen atom. Think about the numbers of protons and neutrons in a carbon atom compared to a hydrogen atom. Now, those numbers would be a complete pain in the backside to use in any calculations. So instead, what chemists do is use something called the relative atomic mass. We've seen relative masses before. It means masses compared to one another. And these can all be found on your periodic table. So you will need to make sure you have a periodic table available for the whole of this topic. You will also obviously need a calculator. Now, the relative atomic mass you'd think might be compared to the lightest of all elements, hydrogen, but it isn't. The reason it isn't is that because in 1961 the first atom that was actually measured accurately was the 12 carbon isotope. Remember, that 12 in front means the mass number is 12. Now, they then based everything basically on 1/12 of 12, which sounds strange, but that's scientists for you. Now I want you to have a look at chlorine's AR. You'll notice something different about it compared with the vast majority of the others. What I want you to do is think about how this arises. So it's unusual and why. We have covered it briefly before, but just pause the video and have a think about your answer. Well, what's unusual is that the relative atomic mass of chlorine is not a whole number. And this arises due to the existence of isotopes. And the relative atomic mass that's given on the periodic table is the average mass for all the isotopes of the element. Your simple GCSE periodic table gives most as whole numbers, but actually the majority are not whole numbers. So now chlorine has two isotopes. One has a mass of 35, mass number 35, and the other has a mass number of 37. Now you may think, well, that should come to 36 as the average, but we calculate what's called the weighted average. This takes into account how much of each isotope there is. 75% of all chlorine atoms are 35 Cl and 25% are 37 Cl. So to calculate the relative atomic mass of chlorine, we take the percentage and mass of one isotope, but we convert the percentage to a decimal, so that's just 75 over 100, so 0.75 times 35. We do the same for the 25%, convert it to a decimal, 0.25, and multiply that by the mass of that particular atom. Then you add the two up, and you should get 35.5. Okay, perhaps technically there should be brackets round that and round that. So, following that formula, calculate the relative atomic mass of boron, given that 20% have a mass of 10 and 80% have a mass of 11. Now pause the video and have a look at that and see how you get on. So to calculate the AR of boron, you do 0.2, so that's 20% as a decimal, times 10, plus 0.8 times 11. So do that sum and the answer you should get is 10.8. To find the mass of a compound, you simply have to add together the masses, the relative atomic masses of all the elements, and that's a key skill we need to be able to do. And if you can't do that, you will find the whole of this topic very, very difficult. The term we use for compounds is the relative formula mass, and you'll see that's got a symbol MR. Now there are some examples on the next few slides. I will run through 2, maybe 3 of them with you, and then I want you to click through on the presentation, which is on my website and on Google Classroom, to check that you get the last few. So here we go. What is the MR of water? Well, before you can get anywhere with these, this is why writing those ionic formulae is important. You need to know the formula of the substance. And the formula of water is, of course, H2O. What does that formula mean? Well, it means that water contains 2 hydrogen atoms and 1 oxygen atom. So to find its relative formula mass, we need to take twice the relative atomic mass of hydrogen from the periodic table and once the relative atomic mass of oxygen, and add that together, or add those together. So twice the relative atomic mass of hydrogen, once the relative atomic mass of oxygen. Look these up on your periodic table. Again, you can pause the video so you've got some time to do that. And you should find hydrogen has a relative atomic mass of 1, oxygen 16. So your sum is 2 times 1 plus 16. And that comes to 18. Now this last line is the key bit of working that you need to put in any exam question. Okay, all the rest here is just stuff to help you out. So for the next question, if you get this and can do it straight away, you can go straight to that last line and the answer. So the next one, what's the relative formula mass, MR, of sodium hydroxide? Again, you need to know the formula to do this. And the formula of sodium hydroxide, you really ought to know by now, is NaOH. So that contains 1 sodium, 1 oxygen and 1 hydrogen. So to find the MR, we need to find the relative atomic mass of each of those. Again, just spend a little bit of time looking those values up. Pause the video so you can find them. So you need the relative atomic mass of sodium, relative atomic mass of oxygen, relative atomic mass of hydrogen. Only one of each, because there are no numbers in the formula. Please make sure that you check which number you are using. Okay, on your AQA periodic table, it is the number towards the top of the box. If you look on the key that's on the top of the periodic table, then it gives you an indication of where to look. Now those numbers are 1 times 23. Again, you can miss out that 1, it's not essential. 1 times 16 and 1 times 1. So if you were to write 23 plus 16 plus 1 in your exam, that would be absolutely fine. Add those all together and you get 40. So one more example before, no, actually we'll do 2 more examples before you then have a look at the final example yourself and then actually do some work on some quizzes with this. So what's the relative formula mass of sodium carbonate? Well, this is a harder formula for you to know. It's Na2CO3. Now, it's CO3 2 minus with Na plus. If you remember, you drag the 2 across down to there. There's no number to drag in front of the plus, so it stays as CO3, Na2CO3. So that contains 2 sodiums, 1 carbon, and 3 oxygen atoms. So again, here's the routine. Relative formula mass is twice sodium's Ar, 1 carbon Ar, 3 oxygen Ars. Okay, please be careful. The number of times I've seen people look up cobalt, that's big C little o, instead of carbonate is quite a few. Carbonate, there's a clue in the name, contains carbon and oxygen. So again, look those up. Pause the video so you've got time to look them up, and then you should have a sum that looks something like that. Again, you can just put plus 12 if you want, it doesn't need to be 1 times 12, and add those all up and you should get 106. So one further example. What's the relative formula mass of calcium hydroxide? Now the formula is CaOH twice. Remember, all these elements, all these iron formulas with 2 capital letters in have to have brackets around them if there's more than 1 required in the formula. It's OH minus, so there's no number to take to after the calcium. But Ca2 plus, so you take the 2 across and put it after the OH. So now the key thing here is what it contains. That 2 there means it contains 2 times everything in the brackets. So 2 oxygens and 2 hydrogens. 2 times everything in the brackets. So look up the relative atomic masses. Again, pause the video so you've got time to do that. See if you can work out what the sum's going to be at the end as well, and see if you can work out the answer without me doing it for you. Okay, so there we go. 1 lot of 40, so you don't need the 1 times, 2 times 16, 2 times 1, and you get 74. Okay, I want you to try that example. You might want to go onto the presentation to have a look and see the actual answer. In particular, I'll show you the formula now. See how you get on with that. Okay, if you look in Classroom, there are links to some exercises I'd like you to do on this.